So yesterday we started section 6.5 looking at right triangles. We defined all the trig functions in terms of using the terms opposite, adjacent, and hypotenuse. And today we're going to use that to solve triangles. Okay, so the idea of solving a triangle basically means you're going to find out how long are all the sides and how big are all the angles. Okay, so you have to find 6 things. But in a right triangle, you're always given one of them. You know one of the angles is a 90. So there's one thing you don't have to find. And I can't just give you a right triangle and say solve it. I got to give you a little bit more information than that. There's 2 different cases I could give you. In addition to the 90, I either can give you one of the other angles and one of the sides, and you can figure everything else out. Or I could give you 2 of the sides. In either case, we can use right triangle trig to solve them. Right, a few things you want to keep in mind when you're solving a right triangle. There's a fact about the angles that's important. There's also a fact about the sides that's important. Anybody think of an important fact about all the angles in a right triangle? Or any triangle, really?
They have to add up to 180.
Okay, so that's something to keep in mind. All your angles in a right triangle or any triangle add up to 180. What about the relationship between the sides? Is there any formula or theorem that you're allowed to use when you have a right triangle having to do with the sides? Cool? Good, Pythagorean Theorem. So keep those 2 things in mind as you solve right triangles. They both help. Pythagorean Theorem, and then all the angles add up to 180. So when we start to solve a triangle, even though we learned 6 trig functions yesterday, we're only going to stick with these 3. The reason is we have buttons for them on the calculator. They're easier to type in. While you could use secant, cosecant, and cotangent to do what I'm doing today, it would be extra work that's not necessary. Right? So we're not going to use them. So first you're going to have to pick which trig function you want to use. Okay, how do you pick it? Well, you're going to have to look at what you're given and what you want to find. All right, let's say you were given the hypotenuse and you want to know the side opposite. All right, so you're thinking, okay, I need to know the hypotenuse. I was given the hypotenuse, I want to know the side opposite. That'd be sine. Sine is the trig function that involves opposite and hypotenuse. If they told you the opposite and you wanted to know the adjacent, now you're using tangent. Because tangent is the only trig function out of these 3 that has opposite and adjacent in it. All right? So basically look at what you already know, look at what you want to know, and then we'll make our decision. All right, so here they're telling us that one angle in a right triangle measures 37 and the hypotenuse is 8. Now they didn't tell us what angle it is. It could be alpha or it could be beta. It doesn't matter. Okay? If you decide to make it alpha and someone else decides to make it beta, all that's going to happen is what you get for A and what you get for B, it's going to switch what somebody else gets. You'll get the same numbers, you're just going to get them in different spots. Okay, so I'm going to make alpha 37. Okay, so generally what I do first is I make a table. Okay, the table is just to organize all the information that I'm given and then the information I need to find. Okay, so I'll start by listing the 3 sides. Okay, in the next column, I'll list my 3 angles. Does anybody remember the name of the angle across from A? We're not doing capital A, small a like the book. What letter did we decide?
Was it alpha?
Alpha, yep. Anybody remember the letter for the angle we use across from B? Yep.
Beta.
Beta. And then the angle across from C, we don't need to give that a name. C is the hypotenuse. So what's the angle across from C? It's always how much? Cody? Yeah, that's always your right angle. Okay? When we start studying triangles that are oblique, okay, or non-right triangles, then we're going to have to give that a name. Right? But in this case, it's the right angle. There's nothing to solve for there. Okay, let's fill in what we know. So the hypotenuse, that's 8. 37 degrees, I decided to make that alpha. So I'm going to put a box around what I need to find. Now, a table is one way to visualize it, and I think that's helpful for writing your final answer. But anybody have another thought of how I could visualize this besides the table? What else could I do? This kind of problem, anytime you have to solve a triangle, it lends itself to doing it.
Draw a triangle.
Yeah, draw it. So you can see what's opposite, what's adjacent, and what's the hypotenuse. It doesn't matter where you put A. Just put alpha across from it. So if I decide to put A here, alpha goes there. I'm only going to label in this triangle what was given. So the 3 things I need to find, I left those as variables. All right, so our goal is to find what goes in the 3 boxes. Is there anything there that I could find pretty quickly without really that much work? You probably could have found this before we even learned right triangle trig. Emily?
Yeah, if find like B, you can do, or beta, you can do 90 plus 37, subtract 180.
Okay, so you could add these 2 angles up and subtract them from 180, because we know that all the angles have to add up from 180. Anybody think of something even simpler? It's basically the same idea, but it would keep the numbers just a little smaller. Yeah?
Subtract 37 from 90.
Yeah, just subtract 37 from 90, because you already know the right angle is 90, so you can forget about that. The other 2 have to add up to 90, minus 37, and that gives us 53. Okay, so now we've got beta. Okay, next we want to find A or B. Okay, it doesn't matter which one we do first. So let's do A. Now to find A, I have to pick 2 other pieces of information to use. Right now I have 3. I have the hypotenuse, I have the 37, and I have the 53. Out of those 3 pieces of information, the 37, the 53, and the 8, which 2 do you think are the best to use? Yeah, obviously.
37 and 8.
Yes. It's not that the 53 wouldn't work. It would. But why is it not the best idea to use that? Anybody know why it's not a good idea to use the 53? Why is the 53 different than the 8 and the 37? What makes it different? Think about how this problem started out. Okay, another way to put it is it's risky to use the 53. Does that help? Yeah?
Because if you happen to be wrong, you don't know what your answer is.
Right. If you made a mistake calculating that 53, we didn't. 53 is correct. It's pretty obvious in this case. But if you did make a mistake, you did it quickly and you wrote 43, and you use that to find A, well, guess what? Now A is wrong. And if you use that to find B, well, now you just got B wrong. The way we're going to solve these problems is you're going to find each answer by always going back to the information that was given. So even if you make a mistake on one part of it, that mistake doesn't have to affect anything else. Okay? Any question on that? That's the reason why we're doing it the way we're doing it. Okay, so let's look at from the perspective of the 37. Okay, our goal is to figure out which trig function we need to use to find it. Okay, choices are sine, cosine, or tangent. Right, so Colby, what's the name of the side that's farthest away from the 37? And your three choices are, yeah, go ahead. Opposite, good. A lot of people say, well, A. Yes, it is A, but she got it exactly right. Opposite. Okay. How about the 8? Augustine, what's the 8?
The 8 is the hypotenuse.
Yep, that's your hypotenuse. So we know the hypotenuse. We want to know the opposite. Which trig function has those two sides in it? Opposite and hypotenuse. Sine. Okay, it's the only one. It's the only one that'll work. Okay, so sine. Fill in your argument. Sine of 37 equals opposite over hypotenuse. Okay, now the last step is to get the variable by itself by moving 8 to the other side. So Casey, how would I do that?
Multiply both sides by 8.
Yeah, multiply both sides by 8. Okay, we need to type that in. Let's see what we got. 8 sine 37. Excuse me. Make sure you're in degrees. Okay, all the problems today will be in degrees for solving a triangle. Okay, so it's 4.815. All right, so now we got to get B. Okay, so we know two sides of a right triangle. What could you do now if you know 2 out of 3 sides in a right triangle? I don't want to give you a hint, but what could you do to find the third side? Yeah? Okay, you could do the Pythagorean theorem. But why am I going to say the Pythagorean theorem is not a good idea? We already touched on this.
Because it could be wrong, so that would make the next side wrong.
Yeah, what could be wrong here?
A.
A. Well, two things. A could be wrong. First of all, it's not. I know A is right. But second of all, it's a decimal. Right? So if you use a decimal that's not exact to find another answer, well, now that answer is going to be even worse. Okay? So the Pythagorean theorem might be a good way to check your answer, okay, when you're done, but I wouldn't use it to find your answer unless you're totally stuck and you have no other choice. Okay, so let's try to find B the same way we found A. All right, so now let's find B. Generally what I do is I just circle with a different color so you guys can see it clearly, trying to find B. I'm going to go back to the angle that was given and back to the side that was given. So I'm still using the hypotenuse. Okay, that's 8. But what's the name of side B? How about Brianna? What's the name of side B? Adjacent. So which trig function has adjacent and hypotenuse? Cosine. So we're going to set up almost the same equation again, except this time it's cosine 37 equals adjacent over hypotenuse. Solve it exactly the same way. Multiply both sides by 8. We get A equals 8 cosine 37. All right, so let's see what we got. So this is cosine 37 times 8. 6.389. Now, if you've got extra time and you want to try a squared plus b squared equals c squared, that's a good way to check and make sure you got it right. Yeah?
Down on the bottom, did you have A over 8?
A over 8. Yeah.
But I thought we were solving.
Oh, b. Yeah, thank you. Yeah, we did b. The answer is still correct. Yeah. So it's adjacent over hypotenuse. Okay, so 8 cosine 37. Thank you. And that's it. So now we know all the sides, we know all the angles. We've solved our triangle. Any question on that? All right, so page 361, number 39. Let's set this one up. Just because something here is going to happen a little bit different, not very different. So this time we know A is 12.3. And we don't have a choice what the acute angle is. They're telling me it's 20. So I want B, C, and beta. Well, I can get beta pretty quickly because I know alpha and beta have to add up to 90. So Jill, what would beta be? Yeah, it's going to be 70. So now we've got beta, but forget about using it, just in case you made a mistake finding it. Okay, next, I'll make my sketch. I'm going to put A over here, alpha, the hypotenuse I don't know, beta, I'm not going to fill that in because I didn't know it to start with, and B. Let's see if we can get B next. Use the two pieces of information you were given. And I circled B because that's what we're trying to find. All right, which trig function do I need this time? Yeah. Tangent, yeah. We want to know the side adjacent. We know opposite. So we're involving opposite and adjacent. So let's set that up. So tangent of 20 equals 12.3 divided by B. Okay, what happens a little bit different this time is the variable isn't in the top of the fraction. It's in the bottom. Right, so the first thing I want to do is get rid of that fraction. So what could I multiply both sides by that would cancel out my denominator? Yeah?
Would you multiply
Just B. Now, normally you've got to be careful when you multiply by a variable because if the variable could be 0, you're not allowed to do that. Okay? Well, I guarantee you B is not 0 because it's the side in a triangle. Okay? Any length of a side in a triangle is larger than 0. So we can multiply each side by B. Now we've got B times the tangent of 20 equals 12.3. And my last step is to divide each side by tangent 20. Now if you look at what we had originally and what I have is the final answer, look at what we did. This was the original problem. Okay? All that happened is the B and the tangent 20, they switched places. So like if you had a problem like 5 equals 3 over x, the answer is x equals 3/5. Okay? All you do have to do is switch what's in the denominator and what's on the other side. The reason why, we just went through all that work. So I might use that shortcut in the future. Okay, let's figure out what that is. So 12.3 divided by tangent 20. It's 33.794. Now in any triangle, if you remember from geometry, the biggest angle should always be across from the biggest side. Smallest angle should be with the smallest side. So I'm expecting C to be even larger than the other two. Okay? A little bit. So to find C, set that up. This time I want C use 12.3 and 20. That's going to be sine again. Okay, opposite and hypotenuse. So sine of 20 equals opposite over hypotenuse. I'm going to use that trick to solve for C. And a lot of these problems, kind of when you solve it, the steps to solve it are the same. So I can reuse what I just had on my calculator if I know how to bring back up the last thing I typed in and just change tangent to sine. Okay, I'm not sure if that's quicker than just typing it in from scratch, but if you want, you can do it that way. So we do. We get a side that's a little bit bigger, 35.963. Oops. Okay, any questions on that? So that's the case where they give you an angle and a side to start with. Let's look at the case where they give you two sides. All right, so in this problem, they're giving you the hypotenuse and one leg. Okay, so the hypotenuse is 12.7 and the leg is 6.1. Now I've got a choice. They didn't tell me which leg it is. Could be A or B. I'm going to make it A. If you decided to make it B, you're going to get the same answers as me. You're just going to get your alpha and beta switched. Okay, on a test, I think I would make it clear. I want you to make 6.1A. I won't leave it vague like that one. So we're going to find B, alpha, and beta. What can't we do right away that we were able to do in the last two problems? And I have to start this problem different. Yeah?
Find the third angle.
Yeah, we can't get the third angle because we're missing both the acute angles. So for now, we'll come back to the angles. But I can get side B. I know A and I know C. So what can I do to find the third side in that triangle? I couldn't do this before, but now I can because I'm being given two sides. Darren?
Pythagorean.
Now I can use the Pythagorean Theorem because everything I'm plugging into it is given. Okay? We're going to need a calculator because the number's not going to come out terribly nice. C squared equals A squared plus B squared. Okay, so 12.7 squared, 161.29. 6.1 squared is 37.21. Okay, subtract the 37.21 from each side. Next to the numbers. So 161.29.21. So we get 124.08. And what's my last step to get rid of the exponent on b squared? Alex?
Square root.
Yep. And so can you explain what you're doing here? Like if you were explaining it to people, if you just said square root it, they might need, well, where, how? They might need more clarification than that.
The square root of 124.08.
Okay, so square root that.
Yes.
And what else?
And the b squared.
And the b squared. So you are taking the square root of both sides. All right, and that's going to cancel. And now our final answer is 11.139. Okay, let's just put it up in our table. All right, so we've got the side. Are we going to use that side to find alpha or beta? Darren? Nope, we won't use it. Okay, let's find alpha. So let's put A, put that as alpha. B, we weren't given, so I'm not going to label that. Beta. And C was 12.7. Okay, so Andy, what two pieces of information am I going to use to find alpha? Definitely going to use the 6.1. And what else? B. That's risky. Why is B kind of risky to use? You could. I'm going to advise you not to. And I'm not going to do it that way. You could, but why is B risky to use? Look at it. It's in a box. What does that mean? Because we what?
Didn't give it to you.
Yeah, it wasn't given to me. Okay, so if it wasn't given to me and I made a mistake finding it, then I'm going to make a mistake automatically again. Okay? So instead of B, what else could we use?
12.7.
Yeah, let's use the 12.7. It's not in a box. It was given to me, so I know it's correct. Okay, Emily, which trig function would I use there?
Sine.
Sine. Opposite and hypotenuse. Let's set that up. So sine of alpha equals 6.1 over 12.7. Now before we solve it, let's figure out the trig function we're going to need to find beta. There's beta, 6.1. 12.7. Brianna, what trig function will I need for beta? Cosine. Okay. Adjacent over hypotenuse. So cosine is adjacent over hypotenuse. Now, in both of those cases, look where the variable is. It's not in the fraction. It's not in the top. It's not in the bottom. It's inside the trig function. Right? So in a second, we're going to solve both of them, but we could start with either one. Let's focus on the one that's on the right. Somehow you need to cancel out cosine. Okay, anybody have a thought on how you can cancel out cosine? We've got to cancel it out so we can get theta by itself. Or alpha or beta, whatever you call your variable. Yeah? Okay, so that's a good thought. Try multiplying it by another function. But really, we can only do multiplication or addition or subtraction with numbers and letters. We can't multiply something by a function. For example, if I said to you, take 3 and multiply by the square root function. A function is something you have to plug a number into. But it's a good thought. Anybody know another way to cancel out a function? Well, you've got to use the opposite or the inverse of that function. Okay, think about when we did the square root. Okay, this is why I made, which problem was it? It's back on this one. Oh, wherever it was, I think it might have been this one. Okay, we did the square root, and I asked very precisely, how do you solve that? Okay. Alex didn't say you multiply each side by the square root. That wouldn't make sense, because square root's a function. He took the square root on both sides. Well, we're going to take something on both sides here as well. Okay. And what we're going to do on both sides is we're going to take the inverse cosine. Okay. We're going to use inverse trigonometry. Okay, so those are your inverse trig functions. There is inverse secant, inverse cosecant, inverse cotangent, but we're not using those yet. A couple different ways you can write it. Most calculators use that notation. Sine with the -1 up higher. An older way of writing it is arc sine. It means exactly the same thing. On your calculator, to do an inverse trig function, generally you press second and then the button. So if you wanted inverse sine, you'd press second sine, or inverse cosine, or inverse tangent. Now, what's slightly confusing about this notation is that -1. That -1 is not an exponent. Okay? If you put any other number there, it is. All right? So if you write something like sine squared x, this means sine of x squared. Okay? If you write sine to the 5th x, it means take the sine of x, raise it to the 5th power. If you write sine to the -1 of x, it does not equal this. It's not what the notation means. If it was that way, you might think, oh, well, when you raise something to a -1 power, that just means to flip it. So when you flip sine, you get the cosecant. So that's just cosecant. No. All right, so this doesn't work. Right? Any other number there besides a -1, yes, it is an exponent, just like I've written in those formulas. But when it's a -1, it's not. It's just the symbol for inverse sine. That's it. Okay, so that. Don't do that. Okay, any question on that? All right, so now let's go back, look at each one of these. Okay, let's start with the one on the left. So we're going to get rid of sine by using inverse sine. So I'm going to take everything that's on the left and I'm going to plug it into inverse sine. I'm going to take everything that's on the right and I'm going to plug it into inverse sine. What happens on the left is inverse sine and regular sine, they cancel out. And now you're left with alpha equals inverse sine of 6.1 over 12.7. And now you just type that in and see what you got. So inverse sine, what was it? 6.1 over 12.7. And hit enter. Okay, it's 28.706. That's alpha. Now, technically, we have 2 out of 3 of the angles. We could add them up and subtract from 180. Or just remember, that's complementary, so subtract from 90. But if you made a mistake, now beta's wrong. So we're going to find beta using the equation that we already set up. This time, I'm not going to use inverse sine. Which trig function would I use on the equation on the right?
Inverse cosine?
Inverse cosine. So take the inverse cosine on both sides, and you'll end up with this. If you want to show the step in the middle doing that, that's fine. Or you can go right to that step. So actually what I'll do is just bring up the last thing I typed in and change it to inverse cosine. So we get 61.294, and that looks good. Those angles look like they would add up to 90. So 61.294. So anytime that they give you a problem and you start off with 2 sides, you have to use inverse trig. Inverse trig is always used when you need to calculate an angle. If you don't need to calculate any angles, you don't need to use inverse trig. Any questions on that one? Okay, so that's the second case. We already went through all that. That's another example which I'm going to skip over. I'll give you kind of an outline of the steps. Step 1 would be to make a diagram. Just like that. Step 2, I'd use the Pythagorean Theorem to find A. Okay, after I use the Pythagorean Theorem, I would use inverse sine to find beta, because beta is opposite in hypotenuse. Those are the sides I know. And then to find alpha, that's adjacent in hypotenuse, I'm going to use inverse cosine. But there's nothing different about that problem than the one we just did. Pretty much the same idea. Okay. Any questions about how you would do that? Okay. And if you want to try it and get the answers for 43, those will be in your book. So you could check that one on your own too. All right. So the last part has to do with unit circle, which we've already done this before. Okay. We looked at all the trig functions on a unit circle. In fact, let's write down what they were. Okay, the sine was y, the cosine was x, and the tangent, anybody remember the tangent? It was a fraction. Darren? If you don't remember it, think about what's another way to write tangent. How could you rewrite tangent using two other trig functions? How about Darren, on if you had to type cotangent into the calculator? Since we don't have a button for that, how would you do that one?
1 over tangent.
Yeah, you could do 1 over tangent. And what's another way? Anyone help them out? Another way you could type in cotangent. Augustine?
X over y. Oh, wait, no.
So what do you, tell me the trig functions. So instead of thinking of x's and y's, like if I was going to type in cotangent, or on a test, I said, tell me how to rewrite cotangent, but you can't use 1 over tangent. What's one other way you can do it?
Cosine over sine.
Yeah, cosine over sine. Or, as you said, x over y. Well, if we can find one trig function in that row, the others are the reciprocals. So tangent was y over x. How about cosecant? Kobe? What was cosecant?
Would it be y over x?
No, y over x is tangent. Think about, you know sine, right? What's sine? What's sine?
Oh, y.
Sine's y. Yeah. So sine is y. If you have the sine, what do you do with it to get the cosecant? Take the sine and
Divided by the cosine?
flip it. Remember, these are your reciprocals. 1 over y. Okay. How about the secant? Brielle?
1 over x.
Yeah, 1 over x. Okay, so these are all the identities we did back in section 6.2. Okay, now we're going to extend them, and we're going to do something else with them. So if we look at it on that circle, okay, what I've done is I've drawn a circle that's radius 1, then I drew a bigger circle, okay, with radius r. Right, if we take a look at the big triangle, okay, in red, And then the smaller triangle in green. What's the relationship between those two triangles? Yeah,
Are they proportional and so?
they're proportional. And what does that mean? If they're proportional, then they're similar. And we learned yesterday that if you have similar triangles, the trig functions in them are the same. The size of the triangle doesn't affect the answer at all. Okay, this is how long your sides are. A bigger triangle or smaller triangle, if they're similar, all the trig functions of the angles are the same. So our goal is if we can take that red triangle and shrink it down to the green one and think of it that way, then we have formulas we can already use. We already know how to do it if the radius is 1. We just have to think about shrinking that red triangle down. Okay, so our radius isn't so big. Let's see how we can do that. So before, okay, the old formulas, okay, got all those right there. But the equation of a circle is x squared plus y squared equals r squared. Well, on the unit circle, r is 1. So that's the equation that represents the circle we had before. X squared plus y squared equals 1 squared, or just 1. Okay, now, the equation that represents that bigger circle is x squared plus y squared equals r squared, but I can't fill in something for r because I don't know what it is. Could be any radius I want. Well, what we want to do is somehow take this new equation and make it look more like the old equation. I want to force this right-hand side to be a 1. If I can, then I can think about this problem using the old formulas. What can I do to all three parts of that equation to make the right-hand side into a 1? Yeah? Do what?
Square root.
If you take the square root of r squared, you just get r. And square root, we're not allowed to take of individual terms. We have to do it to the entire side, like that. That's why in the distance formula, you don't see the square root and the squares cancel, because there's a sum in the radicand. All right, so it's a good guess, but we can't do the square root. What else could we do? And it's an arithmetic operation. Arithmetic operations you can do to individual terms. Add, subtract, multiply. Well, multiply and divide you can.
Can you divide by r squared on everything?
Yeah. You're allowed to multiply or divide. Not add or subtract, but multiply or divide everything by the same thing. And that's perfectly legal Algebra 1 thing to do. Okay, now we're going to get this as our new equation. Instead of writing x squared over r squared, I'm just going to write x over r squared. Okay, same thing. Plus y over r squared. But now the right-hand side is a 1. Okay, now that it's a 1, I can compare the equation I had before and the equation I have now. In the old equation, the first thing that was squared was an x. In the new equation, it's an x over r. Okay, so I'm looking for a pattern here. In the old equation, the second thing that was squared was a y. In the new equation, it became y over r. So from the old to the new, what happened to x? In the old equation, it was x. What did it become in the new equation? Alex? Well, it was x. How about, what did it become? Tried to put the colors around it so you could kind of see what it was and then what it is. X became divided by r. Yeah, so it became x over r. Okay, Okay, and how about y? What did y become?
Y divided by R.
Became y divided by r. So, if you take what I just said and apply that idea to all 6 formulas right there, you will get the formulas that will work on not just a circle of radius 1, but on a circle of any radius. Change all your x's to x over r's. Change all your y's to y over r's. Okay, so let's try that. Let's try it with sine, cosine, and tangent and see what we get. Okay, so before, sine was y. Okay, James, what did we just say y is going to become?
Y divided by R.
Now it's y divided by r. Okay, before, cosine was x. Okay, Jill, what did we say x becomes? X over r. Now, watch what happens when you do it to tangent. Tangent was y over x. So change y to y over r. Change x to x over r. What happens to the r's there? Yeah.
They just cancel.
They just cancel out and it ends up staying the same. So those are the first 3 trig functions for doing trigonometry on something that's not a unit circle. Right? And to get the next 3, okay, you already just copied the 3 on the left, you just flip them. Cosecant is r over y, secant is r over x, cotangent is x over y. Okay, now at first people look at these formulas and they're like, well, wait a minute, you just talked about opposite, adjacent, and hypotenuse. Now you're talking about like an x, a y, and an r. It's the same thing. There's no difference between looking at it as a unit circle or circle of radius r, or as a right triangle. Let me show you why these formulas are exactly the same thing. Take a circle, put a point on it, draw a triangle. Let's call this side x, y, and r. Put theta right there. Okay, so using the words opposite, adjacent, and hypotenuse, what's the definition of sine? Sine is opposite over hypotenuse. Look at what side is opposite theta. Y. Look at the hypotenuse, r. Opposite over hypotenuse, y over r. It's exactly the same thing. No difference between this and right triangle trig. Okay, so now let's use that idea to find the 6 trig functions of that point. Okay, basically, by giving you that point, they've given you 2 sides of a triangle. Okay, they've given you 2 sides of a triangle. You've gone right 2 and up 3. Okay, I'm just estimating it. That's 2. That's 3. But to use these formulas, I'm missing a letter. I've got x. I've got y. Well, before I write it down, what letter am I missing?
R.
I'm missing r. But r is pretty easy to find based on what we've already done. How would you get r here? What could you use? Augustine?
Pythagorean Theorem.
Yeah, the Pythagorean Theorem. So if you go through and solve it, you'll get r is the square root of 13. Now you've got x, y, and r. Fill them into any of those formulas you need to. Okay, so sine is y over r. I'll fix the square root at the same time. Cosine is x over r. And tangent is, you can think of it as opposite over adjacent. Or you can think of it, if your angle is right there, think of it the way the definition says, y over x. It's the same thing. Just kind of two slightly different perspectives of the same thing. And to find the other three, you just flip the three that we have there. Any question on that? All right. So now suppose I wanted to take that information and find the angle. Well, any one of these equations I could use to do that. Let's just pick the top one, sine. Let's go write it down. Sine of theta. How would I solve for theta? How would I get rid of sine? James?
So we can do the sine negative one thing.
Yep, you remember what that's called? Anyone help me out? What's the sine negative 1 thing called? Yeah.
Inverse sine.
Inverse sine. Good. Take the inverse sine of what's on the left. Do it to the right. And let's see what we get. Inverse sine of 3 square root 13 over 13. Inverse sine 3 square root 13. Be careful with your parentheses. I think that should be okay. You get 56.31. So that's how big that angle is. And it makes sense that we should have been able to figure out what it was between, because the point 23 is in the first quadrant. And if you think about all your angles in the first quadrant, this is how you number. If you were on a circle and you started going around, you start with 0, 90, 180, and 270. So if I said to sketch a 45-degree angle, it would be about like that. The dot would be halfway between 0 and 90. Well, 2, 3, notice, right 2 and up 3. If I sketch that angle, well, I know it's bigger than 0, but I know it's less than 90. So 56 makes sense. And it's a little, the way I sketched it, it looks like it's more than halfway. So that seems reasonable. Well, if the point ends up in the second, third, or fourth quadrants, we just have to be a little careful. You can still use the calculator. You'll get an answer. But because of the way the calculator does inverse trig, you're going to have to adjust that answer a little bit. In quadrant 1, you don't need to. Type it in, you're done. But what we're going to do first is for any other quadrant, you're going to start off doing it just like we did. We're always going to use inverse sine. Could you use inverse cosine or inverse tangent? Yes, but it kind of complicates it. Okay, so you're going to take, and you're going to use inverse sine, and you're going to get an angle. If it's in quadrants 2, 3, or 4, that's called the reference angle. To find what the real angle is, in quadrant 2, that's your formula. It's 180 minus the reference angle. And I'll show you an example. In quadrant 3, you're going to add 180 to it. In quadrant 4, you subtract 360 from it. Okay, so you find your reference angle by using inverse sine. And we take those bars there, that's the absolute value of it. Okay, we're looking for a positive value. And once you find that, just follow the formula. If your point is in quadrant 2, do 180 minus the reference angle. Quadrant 3, 180 plus. And I'm going to show you why you have to do that right now on this problem. So they want us to find theta. Again, you have a choice of any trig function you want. But let's stick with inverse sine. Okay, so we've got x, we've got y. What's the letter that I'm missing? I need r. Or I need the hypotenuse, okay, if you want to think of it that way. Let me make a sketch so I can find the hypotenuse. I'm going right 2, down 3. Right 2, down 3. It's kind of like the point we did before, except y is negative now. Well, if I think of these as lengths, r is the same. It's the hypotenuse of that triangle. Square root of 13. Okay, and then what was, x was 2, y is negative 3. Okay. Plug those into your formula. Right here. Okay. Y over r. Right, so sine of theta equals y over r. Again, don't use cosine or tangent to find the angle. Stick with sine. And then take the inverse sine. Let me just write out the final step. Now, I need to find that, but that's not my answer. That's just my reference angle. Okay, once I find the inverse sine of that number. Okay, because the angle that you're really looking at is this. It's more than 90, it's more than 180, it's even more than 270. Okay, it's getting close to 300. Okay, it's quite a bit of the ways around that circle. So what we're going to find right now is just what we call the reference angle. Okay, so let's type that in. Inverse sine of negative 3 divided by square root 13. Okay, it's negative 56.31. Now, I said I want you to, for the reference angle, make it positive. So your reference angle is 56.31. What you really just found was this. You just found this piece in green. I don't want that piece. I want the other piece. Okay? Starting from the red line, going all the way around. So to find that, if you take, hopefully it makes sense visually now, take 360, subtract away the green piece, you're going to be left with the red piece. That's the part that's going all the way around. So I'm just going to follow my formula. 360 minus 56.31. My reference angle. Right, so that arc in red is about 303.69 degrees. 303.69. Even if you don't understand it visually, you don't need to. All you have to understand is use those formulas. That's it. Now, here I wrote if you're in the second, third, and fourth quadrants. Okay? Well, it's possible you might not be in a quadrant. You could be on an axis. Well, if you're on an axis, that's kind of a special case. We saw that we have undefined values, 1, -1, or 0. Okay? Any trig functions for any of those angles, I don't care which one you do, sine, cosine, tangent, secant, cosecant, or cosecant. If you plug one of those 4 numbers into the trig functions I just said, the answer always comes out to either a 1, a -1, a 0, or undefined. How would you figure that out? That's where knowing the graphs of sine and cosine comes in handy. You have to know that. Okay? So you can't really use those formulas if you have one of those angles, because they're not in a quadrant. They're on the boundary between quadrants. So in the homework, if you have one of those, we can talk more about those special cases tomorrow. But they're actually easier because the choices are very limited. You don't have many options. All right, so the homework for tonight, it's on 361, same section as last night, 25 to 34, 40 to 42, 45, 49 to 53, and the last part, 57 and 61, that's the last example I just did. So if you have any trouble with that, we'll look carefully at those two tomorrow.